Hey, how's everybody doing? Welcome back to the Hot Rod Workshop. Today, after my coffee, of course, we're going to talk about sheet metal layout. Now, what you see before you is an absolutely butchered inner glove box liner for a 67 Impala. It was cut in the center to make more space for, I believe, an amplifier, if I'm not mistaken. And it almost looks like they went at it with a dull pencil to cut the hole. The shop glued it together just for the sake of having a template, and the customer would like a metal insert made. So what we're gonna end up doing is taking measurements from the inside of the insert here, based on the fact that it's a little bit thicker than the sheet metal. We're going with a 20 gauge cold rolled steel. This is like almost an 1/8 inch cardboard. And we'll break it down from panel to panel and figure out exactly where we're gonna make our bends, how we're gonna make our bends, and in what order per the tools that we have. So it'll all come together, have a nice fit, and we'll minimize as much welding as possible to minimize the heat and distortion of the panel. Okay, so I made a quick sketch of what the basic layout is going to turn out to be on the flat sheet. I basically took these 4 sections and broke it down roughly, and I'm going to have 2 sides. I'm choosing the largest panel to involve a 90-degree bend for the sides. Now both this side and left side the right side and left side are not exactly symmetrical. So we're gonna have to use these as templates to a degree, but these panels are relatively straight, so we can use them per measurement. Now, grabbing the measurements with the tape measure isn't particularly the easiest way, considering I can't really get an inside measurement. So what I'm gonna end up doing is grab an outside measurement for the flanges on the 2 outsides, and I'll compensate for the thickness of the right and left side 1/8 inch cardboard by taking this measurement and subtracting by a 1/4 inch. All right, so we got our measurements kind of roughed out here. There is a slight taper from top to bottom, so we have to take that into consideration when we make the sheet metal one. And on the sides, I went ahead and took measurements per this particular shape because they are also asymmetrical from one another. And now we're going to transfer this information much neater onto a newer sheet. Now, along with the more clear drawings of the back side of the insert, we're also going to make cardboard templates for both the right and left hand side, just to get the angles right for when we transfer it over to sheet metal. All right, so we pulled our sheet up of 20 gauge onto the workbench here. Sorry for the distance issue, it's kind of hard to frame everything in, but we got our left-hand side and our right-hand side panels with the dimensions copied down, just for reference points and for reference of the angles. In our middle section, this entire middle section does taper out a bit. These 3 panels here are symmetrical, and the one top panel is asymmetrical. The right hand side is a little bit taller at 4 3/8, and the left hand side is at 4 inch. So we kind of have to keep that in mind when we trace it all down. Now we have to transfer everything down to the 20 gauge. All right, so we transferred the dimensions over in the center section of the glove box insert onto the 20 gauge. And right now we got to set the taper. The top dimension, left to right, is 13 5/8, and the bottom is 13 3/8. So we made a square transfer of the larger dimension, 13 5/8, onto the 20 gauge. From here, we want to say, okay, well, our bottom is 13 3/8. That's a matter of a 1/4 of an inch difference. So you split that difference, make a mark on the bottom, an 1/8 inch in from the longest dimension, which is the top dimension. That gives you your starting and stopping point of your taper. And you just transfer that over to your sheet. Now at this point, it would be wise to erase this exterior line so you don't get confused. Just for the sake of time here, I'm just going to place X's on the line that we're no longer using, just as a reminder. And from here, we can use our outside dimension templates to, right side, to place up against our 6 3/4 section, which is what we're going to be bending off of, and line it up to the best we can to the tapered line. And like I said, we're not going to use this template as a measurement device per se. We're going to use it as an angle finder. So line up to the best we can. We're just kind of throw a starting line and a stopping line, just representing the angle that we want. Now from here, we will use the copied down dimensions and find our connection points and kind of finesse it and figure out where we want to be. And that'll give us a much more precise side to this glove box insert. And then we do the same thing on the left-hand side. All right, now from here, as a double checker, since we have the privilege of the old box here, I like to just kind of line her up, kind of roll her over, take a look how close we got. It looks like these dimensions will work out. If it's a little bit bigger, that's okay. We can always trim it down. Now we do have to transfer this area here. This is for the striker area for the glove box door. We have to transfer that over to the asymmetrical area of the pattern. Okay, so we got everything traced out, measurements checked. Now it's time to separate it from the major panel. Remind me to replace those throatless shear blades because this sucks, but we got to the point where I like to call the tin snips area of the scenario here. So we took off the majority of the surrounding steel with the electric shear, then we brought in the throatless shear to kind of nibble away or butcher the panel, if you will. And I could have went in and got these guys too, but I'm not too worried about that. Reason being is the snips don't really want to take off that much material. You'll start to, it wants to curl that metal up, and if you have too much, you just run into a dead stop. What I like to do in areas where we have a fold scenario is, like in previous videos, I like to drill an 1/8 inch hole in these crux areas. So for two reasons. One, it gives you a stop point in the sheet metal so you don't have any kind of overlap with your shear cutting into material you want to save. It also gives a little bit of a relief area for the fold to take place once we bend these sides in. Alright, so we trimmed the pattern down a little bit more. I like to leave about 1/4 of an inch, maybe just a little less, for when I start doing my precise cuts. So I figured now is a good time to mention two common pairs of aviation snips. One's a right-hand side, one's a left-hand side. And the reason for the orientation being important is the right-hand side will curl material as you cut it on the right-hand side, whereas the left hand will curl material on the left-hand side. You want your base material to obviously stay as flat as possible when you're cutting. So you use the right-hand side shears to cut, and you'll notice as you kind of pull up that the waste material will curl to the right. You use your left-hand side shears, you do the same thing, slightly pulling up, and your material will curl to the left. When it comes to this cutaway section for the glove box door striker, typically in this scenario I would find the center of this radius and drill a pilot hole and work my way up, whether it's a step bit or an actual sized drill bit or a twist drill. Use that to gain that radius in just a simple hole, connecting these two lines together and then snipping towards it. This is such a gradual radius, plus I don't have the size step bit to go this size. So I think what we're gonna do is we're just gonna snip away at this and just try to get as close as we can and then hit it with a file to smooth it out. After we cleaned up all these edges with the file and a little bit of sandpaper, any high spots or low spots were brought up with a hammer dolly or the anvil. We are at the point where we want to bend everything together. Now, at this point, I like to stop and take a look at the bends that I have to perform per the tools that I have at my disposal. If anything is going to get in the way of a particular tool, for instance, my finger brake that I have, there is a over 90 bend that I have to perform. So I have to take that into consideration for if I do that over 90 and then I go to make another bend, and now the fingers of the finger brake are going to get in the way of the next bend in line. So what I want to do is taking that into consideration, get the hardest bends conquered first. And if I have to find a different route for another bend, whether it's up against a table with clamps and some flat bar, some angle, what have you, then that's fine, but at least I don't end up in a trap. All right, so we got all these sides bent to where we want it to be. Bottom side's a little off, but I'm gonna focus on the top side for now, have a half decent fit. So we're gonna go ahead and tack these in place. All right, so we're all tacked in place. Got the machine set up to about 30 amps. Got a tack about every inch or so. And now we're gonna finish weld this. We'll weld about an inch at a time and then head over to a far away section of the panel. Try to keep the heat as low as possible to keep it from distorting. we're all finished welded. And now what's left to do is just kind of grind all this down. We're not too concerned about the look of the weld. What we are concerned about is the heat affected zone. Because this is such a thin panel, I don't want this to distort. So I want to keep this heat affected zone as minimal as possible to keep it from distorting and becoming an issue when it comes to fit it inside the car. All right, so I think we could finally throw away this absolutely destroyed insert and throw in the new sheet metal insert. Now, let's get back to the topic at hand, the sheet metal layout. Just a few extra tips I just want to throw out there here at the end. What I used was a felt tip marker, a thinner than usual Sharpie, and this works fine. If you are looking for a much more precise line in your panels, you can use this stuff called Dychem. It's like an alcohol-based dye. I use it in the container like this. They do offer a spray as well. This is good in the bottle for machining purposes. Now the Dychem works great if you're going to be using scribe lines as opposed to using a Sharpie. And this is a lot more precise way to form your lines for bending, for cutting. You just use a sharper than this scribe, and you have a much easier line to follow. Another added tip, if you are in a production scenario and you're doing a lot of the same bends, a lot of the same cuts, I really like these tools. They offer a stop based on the number here. You go off the stop here and you scribe across and you end up with a line 1 inch from the edge. All right, the next step would be to head over to Rob's Rod Shop and hand this over to John and see if he could fit it into the Impala. He's going to be setting the holes for the inside flange and the dash. So yeah, we'll see how she fits. Thanks for watching.